All right, today we are looking at 24.1 and we are looking at creating parabolas by folding. So I'm going to go ahead and have us look at an example here of one in terms of the process of what we're supposed to do. So we're supposed to take a point, just kind of draw a point here, and fold it over so that it is on top of the X. So let's see, I'm going to have to hold this up to the light to do that. All right, so here is on top of the X, and I make this nice little fold. And then right after I do that, I'm going to go ahead and make my line. So I'm going to go ahead and darken that fold because the fold will kind of disappear after a little while. And then here was the one that I just did, and so then I'm going to go ahead and travel up this line until it actually intersects with this point here. And as you can see, of course I just broke my pencil, awesomeness. Here we go. As you can see, this isn't on an exact intersection point, so we're not going to kind of make it closer to that. It really hits right about that spot there. So we're going to go ahead and look at another one. So I'm going to pick this one here and fold this one over on top of the X. And so sure enough, let's just see. Yep, that is right on top of that. And then I'm going to use my ruler to trace the fold. And then I go, this was the line that I did, I go straight up here until it hits that point. So now I have 2 points on here. As you can see, I've already done a few other ones, but we'll go ahead and check it out and see how that happened. So we're folding over this so that it's on top there. So here is my nice little fold that I'm tracing, and this is the one that I did. So then I go all the way up here until it crosses. I've done several of these folds, so I'm going to go ahead and just darken the folds right now so we can kind of see the goings on of kind of what it looks like. This one here, I forget where this one was, so let's fold this one over. I gotta hold it up to my light. Yep, so it's right there. Here is this fold here, which this intersection point right there and right there. So as you can see, what it is that I've created, it's beginning to look a lot like a parabola. As you can see, this kind of curve thing here. So this is one where what we're going to call, this is the focus. We're going to call this line here the directrix. And if you can see, right here is the vertex of this parabola that I'm creating here. So this would be my vertex. And if you can see, this thing here is 1 value away that way, and then a value of 1 away that way. I have some examples of some other ones that my students did in class today. So here's an example of the 4 one. And as you can see, right here would be my nice little parabola that's hanging out here. If you notice, this is 4 away and this is 4 away, and again that is my vertex. And then this one here was 3, so this is a nice looking parabola here, and again this was 3 away and 3 away. So if you look at them kind of one after another, you can see that this one is much more, what I'm going to say, focused around this dot. That's actually why that's called that. This one here is less focused, and this one here is even wider. So you can kind of see the difference between these guys here. This is just a little bit wider than this one, and this one is definitely wider than this one that we're looking at right here. So those were kind of the little parts that we had there, and then we started to jot down some notes. So I'm actually going to go ahead and do one of the 5 and 6, so if you didn't get a chance to do these in class, hopefully you'll be able to get a chance of doing that now. So let's go ahead and look at the 5. For the 5, oh, one of the things that I forgot to just mention to you is that for this one here, this here is going to be my my y-axis, and then we're going to have this one here actually be my x-axis as we do that. So a couple of things you're going to notice. One, the vertex is actually at 0, 0, and then this line is actually below my x-axis. So let's go ahead and do 4 actually, since we're just looking at 4 right here. So 4, this is my vertex at 0, 0. As we said, this goes up 4, so we go 1, 2, 3, 4. This is my focus, which is at 0, 4. My vertex is at 0, 0. And then I've got 1, 2, 3, 4. This is my directrix down here. And the Directrix has an equation. It's a y equals equation because y is staying the same on all of them, and y is equal to -4. Then this is where we needed a point, and there was kind of a pattern that my class looked at today. And if this was 4, this is 4, and then this was 8. And if we look over here at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Do you see? It really is hitting at exactly this point. This isn't a point, this isn't a point, this isn't a point, this isn't a point. Like there's hardly any other points, but this guy right here, this is a nice little point that you can actually use on that one. And so there was kind of a little pattern. So for the 3, it ended up being 3 and 6, and then hopefully you should be able to figure out what some of the other ones were. So we're going to go over here at 8, 4, which means I need to go over 2 more because I kind of ran out of space there. And then this is the vertex, remember, right in between there. So then this is my parabola that I'm looking at. Now, the axis of symmetry is right here. This is where if you folded it, it would kind of match right on top of each other. And so this here, the x never changes, but the y does. So I would say x is constant. X is always equal to 0 for the axis of symmetry. Then for our equation of our parabola, you needed to have a is equal a times x minus h squared plus k. Remember, this is your x and your y value for your vertex, and since our vertex is at 0, 0, and we plug in 0 for each of those, you end up getting just that, which is really easy to work with because then all you do is you take your x and your y and you plug it in. So the y is 4, the x is 8. So we're going to say that a is equal to 4 over 8 squared is 64. So this would be 1 goes into there and it goes into there, what, 16 times? So y is equal to 1 over 16 x squared. Just to kind of make sure you ended up with the correct answer, this one here is y is equal to 1 over 12 and then an x squared. So one of the things that I didn't get a chance to finish in my class today, but you'll need to know for the next day, is that this value right here has a name. This is called our p-value. And the p-values for each of our parabolas is actually given to you in the name. We kind of gave that to you. So this one was up 3 and down 3. And then our parabola went like that with our 6 and 3 and our 6 and 3. So again, this is our p-value. And in this case, my p-value is equal to 4. And this, my p-value is equal to 3. And so you look and you see, well, let's see. This a value is 1 over 4 times 4. So we'll write 4 times 4. This a value is 1 over 3 times 4. So the constant thing that you see in both of these is 4. Over here, you would have gotten y is equal to 1 over 8 x squared, which is 2 times 4. So if you notice, the 2 is the 3 and the 3, the 4 and the 4, the 2 and the 2, but the 4 is what stays constant. So what we find is our a value is really equal to 1 over 4p, which goes both ways. If we already know the p value, I can figure out the a. If I know the a value, then I can figure out the p, which is going to be important in terms of the way that these parabolas are made up. All right, that was like the mother long of our video, but hopefully that helps with what we actually tried to accomplish in class today, especially if you were missing.